right, so we're going to start off, or we're going to finish it off by doing this last question here. Determining VCB. So, it's the last question that's in this list of questions here. So what that means is that if you couldn't do all of these, chances are you can't do this last question, because this last question probably relies on the answers in these questions over here. But if you could do all the other questions before it, then you can definitely do this last question. And usually the last question is usually the easiest question because you're given so much information already. So from the previous questions, we found out that IT over here was like 1 amp. I think, I'm just simplifying the numbers here, but I think it was a little bit less than 1 amp. But I'm going to simplify it so that the questions are easier to explain. Then we found out that this 1 amp is divided into 3 different currents. So I can't remember exactly what the values were here, but if you're doing this question, you would know. This for sure was 0.5 amps. This I think was 0.3 amps, and that means that this one over here has to be 0.2 amps. So 2.2 amps going down this resistor over here, 0.3 amps going down this resistor here, and 0.5 amps going this way. And those all have to add up to 1 amp, of course, because that's the total current. So the question is asking us what the voltage VCB is. So what's the difference between the voltage at C and the voltage at B? So that's VCB. Okay, so let's start off with voltage at B. So from the previous question, where we determined VAB, we found out that the voltage at B is equal to the voltage at A, and that's also equal to the voltage at this node over here. So what's the voltage at this node? Well, what we can do is we can just figure that out pretty quickly. So we know that the voltage coming out of the battery is 30 volts. So 30 volts makes it all the way over here without encountering a resistor. It comes all the way here without encountering a resistor. That means that you have 30 volts that are going through this resistor here, and some of that voltage is going to go down because of the resistance. So we start off with 30 volts, and we're going to subtract the voltage drop that occurs through this resistor. And the voltage drop through a resistor is equal to the current moving through the resistor multiplied by the resistance of the resistor. So the voltage drop, so we'll just say voltage drop. So 30 volts minus the current and the resistance. That's going to be 30 volts minus the current moving through this resistor. So that's 0.3 amps, and the resistance is 10. So what we end up getting is 30 volts minus 3 volts, and that's equal to 27 volts. Okay, so when we get to this point over here, the voltage is going to be 27 volts. Started off 30 up here, and then goes down and becomes 27 volts. Okay, so the voltage here is 27 volts. It means that the voltage at this point over here, B, is 27 volts. So now we know that VB is equal to 27. So let's write that down. So VB is equal to 27 volts. What about VC? So for VC, it's all the way over here, and we have to remember something here that's pretty important. The important thing to know is that no current travels down this path, or 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 any path around here, around this complex of current, complex of resistors. And the reason why is because, well, this electricity coming out of the battery is going to go, and it wants to get back to this negative terminal, right? So it's going to take any path that it can. It's not going to take any path that it can. It's going to take the path of least resistance. So, all the current, it's a lot of current, can't just go through one resistor. So it will split itself among 2 or 3 resistors, that's fine. But when the current comes across a situation like here, so it goes through this resistor, it has the option of going down this network of resistors, or it can just go down this freeway, which doesn't have any resistors. It's all going to go down this freeway, like that, right? So that means there's no current moving around here. So what does that mean? It means that the voltage drop across here, this resistor, is 0, right? Because the voltage drop is equal to the current moving through the resistor multiplied by the resistance. So the voltage drop is going to equal 0 multiplied by the value of the resistance, which is 15. So 0 times 15, that's just equal to 0. So there's no voltage drop there. So what does that mean? It means that the voltage, whatever the voltage is here, is going to be the same as the voltage here. And remember, there's no current moving through like here or anywhere there. So that means that the voltage here is also equal to the voltage here. And the voltage here is also equal to the voltage here, because there's no resistance in the path to cause the voltage to decrease. And we can keep on going, but I'll just leave it there for now. So the point I'm trying to make here is that the voltage at C is going to equal the voltage at this point over here. And the voltage at this point over here can be calculated because we know that 30 volts comes out of the battery and then goes through this resistor, and some of its voltage drops, and then you get the voltage here. So the voltage at that position, that red V, is equal to 30 volts minus the voltage drop across that resistor, this resistor over here. So that's going to be equal to 30 volts minus the current moving through this resistor multiplied by the resistance value. So that's going to be 30 volts minus the current moving through. From our previous questions, we found out that was 0.5 amps. And the resistance is going to be 8 ohms. So it's 30 volts minus 4, which is equal to 26 volts. Okay, so VC, which is equal to that red voltage up here, VC is equal to 26 volts. And so VCB, which is equal to VC minus VB, is equal to 26 volts minus 27 volts, and that's just equal to -1 volt.